All right, hey everybody. So today we're going to divide monomials. Just a quick review of the rules. So the product property says when we are multiplying two items with the same base, then we add our exponents together, okay? When we are raising a power to a power, we multiply those powers together. And when we're multiplying two different numbers together and we're raising that whole thing to a power, we raise each piece to that power. And just a basic reminder of how to multiply fractions or create equivalent fractions. Because remember, if we want to turn, let's say, 1/4 into something with a denominator of 16, we would have to multiply the numerator and the denominator by a product of 1, which 4/4 is 1. Okay, so our numerator would be 4/16 here. Also, more reminders of the quotient property. It says that if we are dividing two numbers that have the same base, we subtract our exponents. And this is just letting you know right here that in this case, our numerator exponent is greater than our denominator exponent, okay? So that means that it stays on top. So you would have a to the m minus n. And keep in mind, if you don't see a fraction there, it's understood to be over 1. All right, now over here, this says that if n is greater than m, that they will stay on bottom and you will still subtract. It's just they stay in the denominator. So let me show you examples of this. All right, so if I have x to the 10th power over x to the 4th power, we get x to the 10 minus 4, which is x to the 6th power. And technically, this is in the numerator, okay? All right, so if we had it the other way around, though, if we had x to the 4th in the numerator and x to the 10th in the denominator, we have more x's in the denominator, so they're going to stay in the denominator. You can't just leave nothing in the numerator, so we're going to put a 1 there. Okay, do you see the difference between this and this? All right, this is probably a relatively big number unless it's negative, and this is a fraction. All right, so here's another example. Where do we have more x's in part A? We have more x's in the numerator, so they're going to stay in the numerator, and 9 minus 7 is 2, okay? Also on part B, our numerator has more exponents, so it would be 3 to the 10 minus 2 is 8. And I don't know about you, but I don't know what 3 times 3 times 3 times, and I can't even think right now. But anyways, we'll leave it as 3 to the 8th for now. All right, check these out. Our denominators are bigger on all of these, so we would have 1 over b to the 12 minus 8, which is 4. And over here on part B, we've got 1 over 7 to the 2nd power. And I can do that easily in my head. So we would have 1 over 49. This is just a reminder that anything divided by itself is 1. Anything, even if you have a variable divided by itself, it is still 1. So if you have x, y, z divided by x, y, z, you still get 1, okay? Anything divided by itself is 1. All right, so this brings us to the zero exponent property, and this is where we get the 1 from. Why is it anything divided by itself is 1? Well, check this out. If I have 2 to the 4th power divided by 2 to the 4th power. Well, remember our rule that says whenever we're dividing, we subtract our exponents. Well, we would get 2 to the 4 minus 4. So we would get 2 to the 0 power, and that is 1, because anything divided by itself is 1. Okay? This is where 2 to the 0 power, anything to the 0 power becomes 1 because of this right here. Anything to the 0 power is 1, right? Okay, so even 9 to the 0 power, that is 1. N to the 0 power is 1. We don't even have to know what n is. We just know that it's raised to the 0 power. Anything raised to the 0 power is 1. Including these guys. Check them out. 5 to the, remember our rule? 5 to the 0 power, b to the 0 power. Whenever you have a product inside parentheses and you're raising it to a power, you raise each piece to that power. Well, 5 to the 0 power is 1. B to the 0 power is 1. This is 1. Okay? Same thing applies over here. I'm not going to go ahead and do all that work. There's no sense in it. But notice how everything that's being multiplied is inside the parentheses and the 0 is on the outside of the parentheses. That means we are raising each and every piece to the 0 power, and that leaves us with 1. So this is kind of just a combination of some of our other rules as well. So again, whenever you have something inside parentheses and you're raising it to a power, you raise each piece to that power. So on part A, we would have 3 to the 2nd power over 7 to the 2nd power, which is 9 over 49. All right. On part B, we would have b to the 4th power over 3 to the 4th power, and 3 to the 4th power is 81. Okay, so on part C, we would have k to the 3rd power over j to the 3rd power. All right, this is just a refresher of the rules, the exponent rules. So if you want to hit pause and copy these down on your paper or take a picture of it with your phone or something like that, it might help for you to have later. All right, so now we're going to do some problems that require that we know all of the rules, okay? So the numerator here, we have a power raised to a power. So that gives us y to the 8th power over y to the 6th power. Now, you're never finished until you have simplified fully, and we can actually simplify this further. Notice that we have more y's in the numerator than we do in the denominator, so we're going to subtract, and so we end up with y squared, and that's our final answer here. All right, for this one, we're going to leave our b to the 12th in the numerator, and we're going to multiply these powers together, and we get b to the 12th in the denominator. And remember, anything divided by itself is 1. All right, so for this one, we have the numerator and the denominator are both being raised to the same power. So I would have y to the 18th power. Remember, power raised to a power. You multiply your powers together. In the denominator, we would have y to the 4 to the 2nd power. Power to a power, you multiply. And now we're going to simplify further. We have more y's on top than we do on bottom. So we're going to subtract. And there we go. Our final answer is y to the 10th power. All right, so what about this one? It's just like that last one. So we're going to have j to the 8th power, 2 times 4, over k to the 12th power, remember 3 times 4, power raised to a power. And we actually, I don't even know why I wrote that equal sign, because we don't have like bases here. J and K are not the same base. So this is actually as good as this answer gets. You cannot do anything else to it. All right, so a lot of people, they tend to focus more on the variables and they forget about the numbers, the coefficients in front of them. And so this is where you have to remember that each piece inside this parenthesis is being raised to the fourth power. All right, so if we have each piece being raised to the fourth power, that means that we have 2 to the fourth power, m to the eighth power. Remember, power raised to a power, you multiply your powers. 5 to the fourth power, and n to the fourth power, because really this n is to the first power right there, and 1 times 4 is 4. Okay, if you can do the math, and I'm not saying necessarily in your head, you should have a calculator that can do exponents, then you should do the math, okay? So 2 to the fourth power is 16. And 5 to the fourth power is 625. 5 times 5 times 5 times 5. And this is as simplified as this gets. These things can get messy in a hurry, okay? So let's do this piece first. So you've got a power raised to a power, which gives you x to the 12th. Let's do this piece next. You've got x to the 10th over, and we're going to do this piece, x to the 30th power. Now remember, according to our rules, if we have the same base and we're multiplying, which two variables that are next to each other are being multiplied, you add your exponents together. So we would have x to the 22nd power over x to the 30th power. Now, we can simplify that even further. We have more x's in the denominator. So you would have x to the 30 minus 22. 1 over x to the 30 minus 22, which is 8. And this is as good as this thing gets. It definitely went from looking like a hot mess to something that was much nicer and cleaner looking. All right, I know sometimes these things can look a little intimidating, but just do it piece by piece. All right, the numerator. So let's take this piece, 10 to the second power. That would leave us with 10 to the second power. That's good. P to the third power to the second power, which is p to the sixth power, over, now I'm going to do this piece right here, 5 to the third power, p to the third power, times 2 to the fourth power, p to the 20th power. Okay, now let's simplify even further. So the numerator becomes 100 p to the sixth. Our denominator, I'm just going to simplify this right here, 5 times 5 times 5. So 5 times 5 is 25. 25 times 5 is 125. I'm going to go ahead and simplify this times 16. And then I'm going to simplify these two by putting them together. P to the 23rd. Okay. Now, I don't know about you. Not that I can't do this math right here by hand. I totally can. 125 times 16. I just don't want to. Grab a calculator and do the math there. So I end up with 100 p to the sixth in the numerator, and I have 2,000 p to the 23rd in the denominator. Now, has your previous math teachers ever taught you this? So this cancels that, and this cancels that. So I am actually left with 1 p to the 6th, which I can just write p to the 6th, over 20 p to the 23rd. I guess I could have simplified the p's now. So now I have more p's on bottom, so I'm going to be left with a 1 on top, and then I've got 20 p to the 23 minus 6 is 17. So my final answer, 1 over 20 p to the 17th. Yikes, that was messy. Here's the original problem if you want to try that again on your own. All right, so sometimes the quotients aren't written as fractions, but you know what? They're done the same way. So we've got 56x to the 7th divided by 8x to the 3rd. 8 goes into 56 7 times. We have more x's in the numerator than we do in the denominator, so they're going to stay in the numerator, and this simplifies to be that. Okay, so for this one, simplify each piece. So because 45 is bigger than 5, we will have our numerical coefficient in the numerator, okay? So 45 divided by -5 is -9. That will be in the numerator. Check out your a's. You have more a's in the numerator than you do in the denominator, so we will have a to the 2 minus 1, which is just a, okay? But look at your b's. You have more b's in the denominator than you do in the numerator, so the b's will stay in the denominator, and you subtract 5 minus 3, which is 2. This is our final answer. All right, so for this problem, let's look at this, 24 and 48. Well, 24 goes into 48 twice, right? So we would have 1 in the numerator and we would have 2 in the denominator. Now, check out your a's. So we've got 5 a's on top and we've only got 1 a on the bottom. So we will leave our a's in the numerator and we will do 5 minus 1, which is 4. Now, your b's are more in the denominator, so they're going to stay in the denominator, and then you'll do 4 minus 3, which is 1. So just to make this look a little bit cleaner, we don't need the 1s in either of these cases. So we have a to the 4th over 2b. All right, right here, 14 doesn't go into 21 evenly, but we can pull out a factor of 7 out of each of those, okay? So 14 turns into a 2, 21 turns into a 3. Remember, we divided top and bottom by 7. Our x's are bigger on the bottom, so they will stay on the bottom, and 11 minus 7 is 4. And then our y's are bigger in the numerator, so they're going to stay in the numerator, and 12 minus 6 is 6. The other thing I want to caution you about is your exponents. Make sure that, like, on your exponents that your your exponents don't look like that, okay? That's a place where I know a lot of professors don't like it. They will not count it correct if your exponent is as big as the base. So make sure you are not doing things like that. That looks terrible. All right, so for this one, the parentheses here just indicate that I am multiplying this times this, okay? So let's go ahead and multiply 6 times 5, which is 30. My x's, I'm going to combine. X squared times x to the 3rd is x to the 5th. Remember, that's one of our first rules that we learned. We add our exponents together when we're multiplying. Y to the 3rd times y squared is also y to the 5th. And then we have this over 3x to the 4th, y to the 5th. All right, so let's simplify. 3 goes into 30 10 times. So the 10 stays in the numerator. We have more x's in the numerator than we do in the denominator, so they're going to stay there as well. And that'll be x to the 1st power, which is just x. And then y to the 5th divided by y to the 5th is 1. So times 1 won't change anything. You're left with just 10x here. This is it. So this is it for this lesson. If you have any questions or need any help, you're welcome to message me. I'll be happy to help you out.